Hello all, in today's lecture we are going to see about multiplexer. What is a multiplexer? Multiplexer is again an example of a combinational logic circuit. There are only two specially designed combinational logic circuits. Of the two, one is a multiplexer. The other is a demultiplexer, which we'll be studying about it in our later lectures. Why is it called specially designed? This circuit can handle multiple inputs at a time. It can handle multiple inputs and then it can route them to a single output based on the control lines. I'll give you the block diagram first and then I'll explain you with an example so that it will be easy for you to relate. Clear? Multiplexer can also be named as MUX. Multiplexer can handle 2 power n inputs, multiple inputs. Clear? And it will give you only single output. This is my input and this is my output. Of the inputs, which input has to be routed to your output is based on your select lines. Clear? These are also called control lines, because these lines are the one which is going to control which input has to be routed to your output. And how many select lines you need? That is, it will require n select lines. If you have got 2 power n inputs, then you will be requiring n select lines. I'll explain you with an example so that it will be easy for you to relate. Clear? I hope everybody has got a speaker in your home, and consider you have got 4 members in your family. Now, consider your family members are trying to play a song in your speaker. Say for example, if you are trying to connect to the speaker via your phone for playing a song. Fine. And your brother or a sister is trying to connect to the same speaker for playing a song using their laptop. Fine. And if your father or a mother, if they are trying to connect your TV to your speaker so that they can hear some program, and every member is trying to connect to the same speaker, then say, let me take it like this. This is my speaker. I've got only one speaker. Fine. And you are trying to connect to the speaker using your phone. So one of my input is phone. Your brother or sister, they are trying to connect through their laptop. Clear? So my second input is coming via laptop. Clear? Now your parents, say your father is trying to connect it to your TV. Now say your mother is trying to connect to your speaker via a CD player. This is your CD player. So this will be my fourth input. Now you are trying to connect to the speaker via your phone. This is you. You are trying to connect. Your brother or sister is trying to connect. Your father is trying to connect. Your mother is trying to connect. Everyone are trying to connect to the same speaker at the same time. These are the inputs. Clear? Now, how will the speaker decide whose input has to be answered now? Because everyone is trying to connect to the same speaker at the same time. Now, the speaker will respond to whom? A question arises. How will a speaker decide whose input has to be answered first? That is based on the select line. Clear? Everybody are trying to connect. Everybody are trying to connect. But the select lines decide whose input has to be connected to the output. Is that clear? Understood the meaning of select lines? Select lines are nothing but the control lines. They take the full control as to whose input has to be answered. Is that clear? These are the inputs. These are multiple inputs. That is what I've told you. These are multiple inputs. And you have got only a single output. Clear? And which input has to be connected, which input has to be routed to the output is based on your select lines. Clear? There are so many examples for multiplexer, like for data transmission, data routing, even the radio transmission. Instead of these inputs, say if you example of a radio transmission, there are so many channels that is getting broadcasted. This is channel 1, channel 2, channel 3 and channel 4. And every channel has got their own frequency. Right? The user, if he wants to connect to a particular frequency, that is if he wants to connect to a particular radio channel, what he will do? He'll make use of the tuner. These tuners are nothing but the select line. Based on whatever frequency is being tuned in the tuner, accordingly you will be getting connected to one of the radio channels. Understood how the radio transmission is getting worked and how we are getting the output. Output is going to be only one at a time. That is, you can listen to only one program at a time. So many frequencies are there where the program is getting broadcasted. But you cannot listen to all the frequencies at a time. At a time, you can listen to only one frequency. But to which frequency you want to connect, that is based on the select lines. And accordingly, you'll be listening your program. Whatever program is getting telecasted, you will see that program. Is it clear? I hope you're clear now with what a multiplexer is, the basic concept of how the multiplexer is going to work. Clear? Okay, coming to the theory part, we can design the multiplexer based on the number of inputs. Like we have 2:1 multiplexer, 4:1 multiplexer, 8:1 multiplexer, 16:1 multiplexer, and it keeps on going. You very well know multiplexer has got only one output, so no change in your output. Only your input differs. Depending on your input, we will be designing your circuit. Let's take 2:1 multiplexer first. Clear? For a 2:1 multiplexer. How many inputs you have? You have got two inputs. Always you have to mention your inputs in terms of 2 power n. So it is nothing but 2 power 1. Depending on the value of n, we will decide how many select lines we want. Right? Here what is the value of n? N is equal to 1. So how many select lines will be having? We will be having one select line. Clear? Your output is going to be only 1. That you very well know. Now, how to design this? Give me the block diagram first. 2:1 multiplexer. How many inputs you have? You have got two inputs. Let my inputs be I0 and I1. How many select lines you have? You have got only one select line. So let it be S. How many outputs you have? You have got only one output. That is, let my output be O. Now, after drawing a block diagram, what is the next step? You have to draw a truth table. Now, how many select lines are there? You have got only one select line. And how many outputs you have got? You have got only one output. If you have got one input, how many combinations are possible? 2. That is 0 and 1. Clear? Now, depending on the value of S, we will be deciding which input has to be routed to your output. Say, these are my inputs I0 and I1. And I've got only one output, O1. And depending on S, if S is equal to 0, then I will route I0 to my output. Is it clear? It is something like a switch that gets connected. In case, if my S value is equal to 1, then I'll be routing I1 to my output. Understood? This is how I'll be deciding which input has to be routed to your output. That is based on your select line. Clear? When S is equal to 0, I'll be routing I0 to my output. When S is equal to 1, I'll be routing I1 to my output. Understood? This is how you'll be filling your truth table. After doing your truth table, what is the next step? You have to find your Boolean expression. Give me the expression y is equal to, by default it is SOP. If S is equal to 0, then you have to represent that with a complement. If S is equal to 1, then you have to represent it as such. Clear? Now, how do you give this? This is S bar. Since S is equal to 0, I have given S bar into I0 plus. Here S is equal to 1. So you have to mention it as such. So this is nothing but S into I1. S into I1. Is that clear? This is how you'll be giving your Boolean expression. So what is the next last step in your combinational logic circuit? After finding a Boolean expression, you have to design the circuit using logic gates. Now try to design it. Take the select lines. S is equal to 1 and in case S is equal to 0. Here S will become 0. Clear? How many inputs we have? We have got I0 and we have got I1. We have got two inputs. Fine. Now, based on your expression, what is the first term? First term is nothing but a product term. That is S bar into I0. For a product term, which gate you will be using? AND gate. S bar, S equal to 0 meaning it is S bar. Right? So, S bar, I'll take and lead from here. S bar into I0. These two, I have to feed them inside an AND gate. So, what is the output? S bar into I0. Clear? Now, what is the second term? It is S into I1. So, S is here, I1 is here. So, I'll take these two. Here again, it is a product term. So, I'll feed them into an AND gate. Clear? These two terms, both these two terms, what they have done? They have done an addition. So for addition, which gate you'll be using? You'll be using an OR gate. This is my final output. Why? Understood how to design a 2:1 multiplexer? Whenever it comes to designing, there are 4 basic steps that to consider in mind. These are the 4 steps that you'll have to keep in mind. What are these steps? Whenever the word design is mentioned in your question, first you have to draw your block diagram, followed by your truth table. Then you have to find your Boolean expression, and then you have to design using logic gates. These are the 4 steps that you should always keep it in your mind whenever you see the word design. Is that clear? In a similar way, we will also try to design 4:1 multiplexer, 8:1 multiplexer, and 16:1 multiplexer in our later lectures. I hope you are clear with this lecture. Let's sum it up. In this lecture, we saw what a multiplexer is, how to draw the basic block diagram of your multiplexer, and we try to explain what a multiplexer is using various examples also. Fine. And then, depending on the design, we chose 2:1 multiplexer for today. So for designing a 2:1 multiplexer, initially we did the block diagram, and then from the block diagram we got the truth table, and from the truth table we got the Boolean expression. After finding the Boolean expression, we try to implement the circuit using logic gates. This is how you'll be designing a 2:1 multiplexer. I hope you're clear with this topic. If you find my lectures useful and informative, please do like, share and subscribe to my channel. Thank you.